Hello there. Well, my name is João Malheiros, and yes, it's me again. And today I'm here to talk about some general concepts on AI on Rails. This is the first episode, and the idea here is just to start entering in on some concepts related to AI. Um, let's start. And first things first, why talk about AI? I hate AI. I think it's the thought of a lot of people there, and I got you because I
Hello
also
there.
don't like so much
Well, my name is
how we're using AI and what we think that AI is gonna work on and everything because I don't think it's that revolutionary, but it's here to stay. Right now, it's already changed the way that we work, the way that we study, the way that we search on the web, and I think the problem is that we expect that we're just gonna ask some random stuff to an AI chat and it's gonna have all our answers and it doesn't work that way because AI is somewhat dumb. It's like more like a it has all the knowledge in the world. It can have all the knowledge in the world, but it doesn't know how to infer some questions. So that's the main problem. That's why we need to be specific on that. The other stuff is that AI has more uses than resume stuff and creating media, and yes, it has. And however, to make a good use of a tool, we first need to understand the tool. So that's what we are going to talk today. Again, we're going to talk about some general concepts related to AI, how it works, and what it uses, some techniques and everything. And this class is just to make you understand the next time that we're talking with your friends about AI and everything, what they're talking about when they say tokens and context window and RAG and everything. That's the idea of this talk. So let's start it. First, we're going to talk about introduction, about intelligence, and then we're going to talk about LLMs, techniques, and chants. That's the last part of it. We're going to quickly talk about chants that we're going to use on the next episodes. Intelligence on software development. I think that's important because it's not a new idea. It's a no discussion from the 50s and everything. The first intelligent algorithms are really old. They're based on mathematics and probability, and they're mostly related to adaptability and decision making. So, what's the idea about intelligence? It's that we can have some algorithms that make decisions without knowing perfectly the the options. Like they can adapt. That's the idea of intelligence. And we had this discussion for a long time. Um, then you can ask me decision making. Can't we have this with if house? That's the easiest way of decision making. Like if it's not if this, do this. If that, do that. But the main idea of an intelligent algorithm is that we are gonna have something that adapts for the ifs that we have not written. So it's gonna take a look at a third possibility, like uh, one I have predicted the one and the two, and it sees the three and can do something. That's the idea of decision making. Like it grabs a new possibility and then answers relating to that. And thus we have the one of the most um, definitions of intelligence. That is the ability of an agent to perceive its environment and take actions that maximize its chances of achieving its goals. So I have a code that can make the best decision based on what it knows and on the output, on the environment itself. The environment, we have the question and we have the characteristics. That's what defines an intelligent algorithm, an intelligent software development. And then one more question. Okay, so you say that we have this knowledge and this theory since the 50s and the 60s and stuff like that. So why right now we're having the boom of AI and everything? it's a simple question and have a simple answer. It's because it's now accessible. That's it. And we use it to have AI on some algorithms and systems, but they were really heavy to run on, and the the infrastructure that we have right now makes AI accessible. That's what ChatGPT did. That's what OpenAI did. That opened the whole market. That we have a chat where we can talk with it, and it's gonna give and return you questions. That technology already existed before, but was not that refined to be accessible for everyone, and that's where they broke the broke the everything and the way that we right now do a lot of stuff. We can fetch the chatbot example and to illustrate how AI, the AI that we know as ChatGPT, at Gemini, at Grok, has changed our daily basis. Chatbots were always useful, uh, but they were restricted to the answers they were programmed to. We all know that when we try to, I don't know, maybe fetch a bill or something, that we have some options there, or when we go to a support, that we have some options there. And when we wanted other stuff, we needed to talk to a person. So now we have chatbots with AI that they can adapt to new questions. That when facing a new problem, AI can generate new answers based on what is known and on the question. The problem is that, as I said before, AI is somewhat dumb. It doesn't know a lot of the time. It doesn't know most of the time. It doesn't know what is a good answer. So it's not always good to let AI do all the work. It's one of its problems. And then we're gonna start now talking about what has changed and some concepts of AI that right now exist and that are important to know, because you don't want to be that guy on your friends round table that doesn't know nothing about. People are talking about LLMs and tokens and everything, and you're right. Mm, yeah, good, nice. You don't want to be that guy. So but let's talk about simple concepts, general concepts, and that's it. LLMs. I think it's the first thing that you need to know about general concepts, because um, what do we have right now in most of these AIs is that we have LLMs that are large language models. As I said before, one of the things that ChatGPT brought to us is now AI is accessible for everyone to use it to make it better their daily flow or workflow. And the other thing is that right now we have AI that can understand human language. I can talk to it in Portuguese, in English, in Spanish, in a way that I would talk to a friend or something. And that is revolutionary because it makes accessible. It's one of the parts that make AI accessible. LLMs are based on deep learning algorithms. You have uh, an infinity of knowledge on the internet, on the World Wide Web, and AI is able to learn what is there and to map what is there using deep learning algorithms. And in the end, LLMs are a probabilistic text engine. What it does is that when I gave him a question, he understands what I'm talking about and then generates an answer based on the probabilities of being right. That's the idea. It's probabilistic. And I think that's amazing because in the end, everything is math and probability. I don't know if you guys have seen Moneyball, for example, the movie that talking about baseball with probabilities, or and we have a lot of analytics on every system that we work on because that is essential. Math is the language that we use to explain phenomena accurately. So when we talk about probabilistics, when we talk about math, we're trying, and big quotes on that, trying to preview the future, to see the future and preview what would be adequate to talk about, and that's what AI does. It fetches a question, it tries to understand what you're talking about, grabbing some bits of knowledge, and then generates an answer based on probabilistics. So, and when you say to her like, "Is the sky blue?" The most probable answer is yes, and that's what it answers. That's the idea behind it. Talking about LLMs and going on this line of work, we have some types of LLMs. The first one is a retrieval model. Retrieval models, they are like librarians. They search through a large database and they find what is most relevant to you related to your question. Examples, you have a bunch of laws and everything, and you want to search a specific law, or you have a bunch of documentation that you want to search on. Retrieval models would be perfect for that because they just fetch and return to you what you want to based on your question. They do not generate answers, they just fetch what they found. And you can think there as a librarian where you ask where some book is and it fetches for you, or you can also think about as the best search engine in the world because it understands what you're asking and finds content related to what you're asking. We also have generative models. They are like artists because they create new text from scratch based on patterns and relationships they learn during training. So they understand what you're asking and they try to generate an answer for you. And they can generate media and other stuff, also not only text. Uh, as I said before, the retrieval models, they were accurate because they searched on a database. The generative models, they sometimes are not accurate because they are trying to give an answer. And as I said before, AI is somewhat dumb. It doesn't understand perfectly what we're asking most of the times. So to fix that, we have the hybrid models. They search related stuff and then generate an answer based on the retrieved material and its training. It's important to have training because, and then he's gonna learn what is right and wrong, like a kid. Like you say, oh, you can't do that, you can't paint walls because it's wrong. Oh, you should do your homework because it's right. So that's what we do to LLMs as well. We train them today for them to understand, like, okay, so you've done right, you're absolutely right. So they can give us accurate answers. That's the idea. And the hybrid models, they also use the database to construct these answers. Um, Now talking about how concepts related to the LLMs work. We're talking about types. Now we're going to talk about tokens. I think it's the basic thing of the out. That's the basic unix of text that an LLM processes. In the image, you can see it like the fishes are tokens. Like it's the smaller unit that it can process. And we have a lot of work here because LLMs also need to understand which tokens are used for or which tokens are not. For example, if I ask for it like, and give me a fish, the most important token on this whole phrase is fish. It's what I want. The rest of it is not that relevant. So we have a lot of tokens, but they need to select which tokens are relevant. And they need that because we have context windows. It's the maximum number of tokens the model can consider at one time. Like the table is the number of fish that we can have on the table itself, on the chop table. So we need to determine which tokens are important and which ones are not, so we can have the most um, efficient context window. And also we have different context window for different models. Um, more expensive models have bigger context windows because they can understand more and they can return more data. It's important to also know that. And in the end, we have the parameters that are the LLM variables that are set during training. One example is the temperature. that when it's slower, the LLM is less creative generating answers. And this is important because when you train an LLM, we train it for a specific type of work. Like we have presets of LLMs to answer things. An LLM that generates images, it's going to be essentially different from the LLM that understands text and returns text because they're going to have different parameters. Their usage is different. And this is important because that way we can adequate an LLM to our work, to what we want to use it for. And these are the most important concepts related to LLMs because you're always gonna hear that, oh, this model like ChatGPT 5 is gonna work way more tokens. It has a bigger context window, or you're gonna also tokens are the coin for billing. So you pay an LLM related to the model that you use to choose and the tokens that you use it. So it's also important to understand this so we can optimize it and use it on a better way. As we said in the beginning, you need to understand the tool to use it. So you now have the basic knowledge of of the concepts related to an LLM. So you can now understand billing of an LLM and most of the text related to LLM, basic text. Reviewing it, we have the bread oven. If you think that each bread it's a token, the context window of that oven is gonna be the number of breads we can have. And the parameters are the internal settings for that bread oven, like the temperature is gonna work and how and the time the how much time is gonna be beyond and everything. So you cannot put more breads if the context window uh, the oven is already full, and it's not gonna work the same for different temperatures and parameters. That's the idea of what we discussed about today. Let's go talk about some techniques. First one, the basic one, direct prompting. It's what we do on ChatGPT. We just ask it for something and we get a response. And this technique relies on the prompt. So if I have a better prompt, like in the image, the cat is just saying fish, and the market man is just returning a tuna to it, the seller. If I want, like for example, I want I don't remember the name of a different fish. I need to be more accurate. I need to have a better prompt like, oh, I want a big yellow fish that have like 5 kilograms and something and everything else. If I only say fish, I'm giving room for the AI to hallucinate and return me what it's training, work it on. So that's a problem with direct prompting. But in the other end, I can ask it anything. I can ask it everything, and I have uh, I have a low cost for implement this because I just need to integrate to a chat or even just open the chat, and we're gonna have there the direct prompting. One thing also important is that the evals. It's the way that we score and judge AI responses. We talked about training, but we need to evaluate the AI responses on training to make it accurate, to make it trained, and then we can put it to usage. AIs can be evaluated based on self-review, like it can self-review it. It's not that accurate, but it can be done. Another AI can review it. We can have an AI trained to review AIs and everything. It's a little inception, but we can have that. And we also have the human review that have the best results, but of course it takes more time. So when we it's a technique that of training that it's needed to measure model accuracy and improve model accuracy. I'm training it. We also have the guardrails that where it's the way that we filter questions and harmful, offensive, or problematic content on the prompt. We can also fine tune if like we don't want to hear about other stuff or some private property and block this content. We can also block answers, and we can also use it to other stuff like I want to prevent myself from prompt injection. We can use guardrails for that. You can think it as a firewall of a website. The idea is just to block stuff that we don't want to on both ways. We can see it here like I have a query. Is my query okay? If it's okay, I can put it to the LLM and it can work. I have a response. Is my response okay? If it is response, my response is okay. I can also keep going with the flow. That's important. Like this is where I filter, and that's why sometimes you want to ask AI ChatGPT for an answer, and it says like I cannot answer about that. And an example of guardrails that we are going to have right now is the one that GPT is not going to be allowed to talk about economics. That's an example of filtering, and it's an usage of guardrails, for example. For last, the techniques, we have the retrieval augmented generation, the RAG. What is the idea behind the RAG? It's like I'm not gonna trust only on the prompt. I have a prompt, but I'm gonna also search for content to make a better question and generate a better answer. So that's what the cat's doing. Like he has a question, he reads it on the database, and he also combines with his creativity to generate an answer. I'm going to combine the user prompt to relevant knowledge searching to generate the response. And that leads to more accurate response. But I need a knowledge database to work with it. For example, to do RAG, I'm working with specifics. So I'm going to need a knowledge database to also have some content to make to increase the prompt because if I don't have any database, I'm just doing direct prompting, and again I'm back to being inaccurate. um, One example is that sometimes when you ask about some specific questions, oh, we can use the example of Cloud Code. Cloud Code is already trained to work with code and has some databases. I can give it context so he can work with the context that I gave it to him, and he will also generate an answer, but searching for more for documentation and everything before giving me an answer. That is important because that it's an example of RAG. And these are the most basic techniques that we were going to talk about because we have other ones. We have some other concepts like a rebranker, a rewriter, and a scorer, and some other um, AI concepts that are used in general in these flows. But most important is that we know what is a direct prompt. That is when I question and it answers without doing anything else. We know about evals, that the way that I understand and evaluate what the AI is answering for me to make it better. We know about the guardrails that blocks what I don't want to talk about or what I don't want my AI to talk about. And we also know about RAG, that is like, you remember in the beginning when I said about hybrid types of LLMs? This is an example of technique that a hybrid type can use. So let's gonna close talking about chance. Right now, the most known ones are will be LLM that provides a chat interface, a chat. In fact, it provides a wrapper for most of AIs that we have on the market. But it can also provide you with a chat interface if you want it. It has a generator to just provide you a chat, quick and easy. And if you just wanna test, like I wanna try using ChatGPT outside ChatGPT, you can put it and run it really easy. We also have the OpenAI Ruby, that is a SDK to work together with OpenAI. And I have the wrappers for the API and everything. That's useful. That's amazing. And one example that we saw on the Tropical Rails is the Active Genie, where I have a lot of how can I say that? I have a lot of classes that I can use to compare stuff and do other work on AI. It's an amazing gen as well. So I think these three are what we're gonna explore on. These three are what we're gonna explore on the next steps of this AI 101, and I think it deserves a look at least. So if you got here, just take a look at these three documentations on GitHub, and that's it. To end everything, just thank you. And as I said, this is an introduction. We're just having general concepts, and then on the next episodes, we're gonna have more code and more examples. So thank you for watching this, and wish you the best.